There's a whisper going around that RAG is dead. If true, why should we even care about choosing vector database? What is a vector database anyway? How does it differ from traditional databases? What do they mean when they say they are purpose-built vector database? Where do you even begin? How to pick the one for your production use? By the end of this video, I promise you have a much clearer and better understanding of all these questions, and you'll walk away with a clear decision-making framework for your project from prototype to production. So what is a vector database? A vector database is a specialized system built to store, index, and query high-dimensional vectors, also known as embeddings. An embedding is simply a list of numbers that captures the semantic meaning of unstructured data, such as text, images, or audio. Two descriptions that mean similar things will have embeddings that are close together in vector space. If we look at the animated film, Spirited Away, it's closer to Howl's Moving Castle because they're all made by Studio Ghibli. How does it differ from a traditional database? Traditional databases like PostgreSQL or Redis are optimized for exact matches or range queries. They answer questions like find articles with brand equal to X. A vector database, on the other hand, is optimized for similarity, finding the best matches, not necessarily exact ones. They use algorithms such as hierarchical navigable small world to efficiently locate nearby vectors in high-dimensional space. You can think of it like finding friends of friends in a massive social network just a few hops away. So when do vector databases shine? Here are some real-world use cases where they truly stand out. Retrieval augmented generation, power your AI app to retrieve relevant context before generating responses. Recommendation system discovers similar articles, products, or user-based behavior or preference patterns. Hybrid search, combine keyword and semantic search. Now the question number one is, do you build a retrieval augmented generation, recommender system, or do you have a need for hybrid search? If you are not building all those systems, then you probably don't need a vector database yet. However, if your answer is yes, then the second question you wanted to ask is which camp should I pick? Because there are actually two camps of vector database. So the camp one is traditional database with vector extensions, and key players in this camp including pgvector, OpenSearch, MongoDB Atlas, Elasticsearch, Redis. And camp 2 are purpose-built vector database, which they do vector operations from ground up. And key players in this camp including Weaviate, Chroma, Pinecone, and Qdrant, and this is Milvus, and this is Weaviate. In order to pick this, you wanted to consider your existing infrastructure. Are you already using this traditional vector database like Postgres, Elasticsearch? If your vector operation is only a small part of your app and maybe you do operations less than 1 million vectors, and also you might need to accept the limitation. That is, when you are filtering, you can only do post-filtering. What it means is that you might do the vector operation first, and then you apply your metadata filtering, which may not give you, after the filter, you might have less request number of items. However, for pgvector 0.8, I believe you can set a parameter to relax the filtering, so it will incrementally find more items that met both the metadata filtering as well as the vector search part. However, if you do have millions or billions vectors, and the latency is really important for you, and most importantly, if the core functionality of your app involves lots of vector operation and metadata filtering, then you do want to consider purpose-built vector database. So if you decided, okay, I am going to pick the purpose-built vector database, all those options, how do you pick one for your production use? I attended 2023 LLM Bootcamp, and one of the instructor, Josh Tobin, came up with a very thoughtful framework. And because this is such fast-moving field, I decided to take inspiration from that and do an updated version based on my past 2 years of experiences using vector database. And here are the 5 criteria I came up. I think it's really important for production use cases. The first is hybrid search support. So some of the vector databases require you to set up sparse vectors and dense vectors separately as a separate index. And when you do hybrid search, you need to query both index and merge the results by yourself. But some other vector databases like Weaviate, they have native support for hybrid search. So this one is really how manual or how seamlessly or easy for you to do hybrid search. And the second thing, I cannot stress this enough, is metadata filtering. Because in real applications, whether it's search, recommendation, or RAG, you rarely just like pass the query and do the vector match, do the similarity search, and call it a day. A lot of the times you do have your business logic. You do want to apply additional filtering, and how easy it is to apply this metadata filtering. What kind of data type do they support? Do they support geolocation filtering? Do they natively support daytime filtering? And also, what's their filtering strategy? Do they do pre-filtering, post-filtering, or HNSW aware metadata filtering? And the third thing is schema flexibility. Your data will change, and when you involve your data, when you wanted to add more data to metadata filtering, how easy or how painful it is for you to involve the schema. Can you easily do metadata index update? Number 4 is ease of implementation. When I think about implementation, the first thing I'm thinking about is, do they have free tier for you to try? And do they have good documentation with both the clear explanation for the concepts as well as tons of code examples? I think this is very important nowadays for both human engineers as well as AI coding assistant, because that will make your prototype much easier. And number 5, of course, is cost, and we'll look at each of this in detail. Okay, last but not least, let me walk you through my repository. So let's first have a quick look at the structure of the repo. So first, you will see this data folder, and that has a sample articles JSON data, which has about 100 articles with item source, item title, item subtitle. And then in this docs folder, you will find basically those are all setup guide for each vector database. For example, in any of those, you will find what's the way to sign up for the free tier, and how do you set it up, and how do you get your environment variables. And then in this notebooks folder, showing you the actual implementation, say from Qdrant, you will see the setup and imports, and how do you load embedding models, how do you load your data, and then how do you connect it to your vector database, create a collection or create an index, and how do you generate embedding and observe data. So from section 1 to section 6 is pretty much the same structure for all vector databases. But starting from section 7 and section 10 are the same kind of queries, but it's to run all on different vector databases. And so, for example, in section 7, you can see the basic semantic search. You will have queries like most haunted hikes in the US, and you will get the results from outside article and from climbing magazine. And metadata filtering, you can filter by a target category, and you can filter by date range. So this section you will see differences because some of the vector database has native support for datetime object, and some of them you have to convert it to Unix timestamp. And then the combined filter to show you how can you do both. Basically, you do both the vector operation and you also do the metadata filtering together. And you also have like maybe specify the ideal time range you want the results to come back. For this test, I only have 100 articles, but fortunately, all the vector databases gave me the requested number of results. Sometimes you may not get the request number of items because the setup for the filtering, because it's depend on whether they do the pre-filtering or post-filtering. From section 11, those are typically code apply to that specific vector database because they may have its own unique features that are not available for other vector databases. And then the performance summary is basically run a same set of queries and you can get the performance and see what's the average query time, minimum, maximum, and these are the basically the output we use to generate the final dashboard. Another thing I wanted to call out is like in 2023, I remember when they compare vector databases, they were mentioning that embedding management is a function you might want to consider. What it means that you don't have to call a separate embedding model, you don't have to call OpenAI embedding model. Maybe you're just directly using the vector database and they have the embedding function for you. However, I don't think that's very important anymore because most of the time, it's just like 2 or 3 extra lines to call the API to get the embedding process. So I didn't include that in my 5 criteria. And I also have a helper function in the data loader. You can see this is the helper function to help you get all the metadata from your input. Then you have a consistent way to observe your data. Another thing is the embedding. So basically, you can just write one embedding function called embedding generator and replace this with your embedding model or maybe OpenAI embedding or some other embedding model. And then you can keep all those the pipeline basically the same. You can embed text that is the single query for your input query, embed batch that is to observe your data in batch. And then the final part is this front end. So this front end directory is the live interactive comparison app built using a built-in React and TypeScript. You can see how the benchmark results are visualized. I'm going to show you that right now. So this is the app. So you can see this is the 2025 October
edition because I just did that, and hopefully this is still pretty up to date. So the performance, I wanted to do a disclaimer because I didn't run a very large data set, but those are all like real data we would do in production. And those are also the query we really wanted to run for our app. And so data set, it's only 100 articles, and embedding model, I'm using the free one, sentence transformer, and test query, I use 5 test queries for all vector databases and tested different metadata filters using cosine similarity. And then the key findings is both Milvus, which is also, and the cloud version is Zillis Cloud, and Weaviate, they are all like pretty fast, like 50 milliseconds. Qdrant is also not bad. It's less than 100 milliseconds. Pinecone, what I tested is Pinecone serverless, 100 milliseconds, also pretty good. So Chroma is the slowest. Milvus, Zillis Cloud is the fastest. And Weaviate, actually, I find has the best documentation and lots of good examples. Qdrant is great for metadata filtering and metadata index flexibility. That is, you can involve your metadata pretty easily. Pinecone, very easy to set up. That's also the reason why we chose it 2 years ago. And here's the summary table, the prominent users for each vector databases. Qdrant, they have TripAdvisor, HubSpot, Weaviate has Stack Overflow, Pinecone has Notion, Milvus, Zillis, they have Walmart, eBay, large scale enterprise. And another thing I want to call out, I didn't add it to this comparison. That vector database is Vispar. It's used by Spotify. And hybrid search capabilities, Weaviate is the best. It's like one line and you can do hybrid search. And Qdrant, you specify your sparse index and dense index, and you can use one alpha parameter to adjust how much weight you wanted to use for each one. So that's also pretty easy to do. Those 3, I think they're a little bit more manual in terms of hybrid search. For metadata filtering, the best ones are Qdrant, Weaviate. Pinecone is limited because of this schema flexibility. I believe Pinecone is going to have a new feature for better metadata indexing. So that might help both the metadata filtering and also the data schema flexibility. If you upserted all your metadata at day 1 and by day 30 you have another column you really wanted to add it for metadata filtering, you can't. You can only do that for post filtering, but you cannot add a specific filterable metadata index for this new field. So that's why I gave it a limited and poor flexibility. Ease of use, I think they are all basically pretty good, especially with the coding assistant. You can get those code running pretty easily. And they all offer free tier, and except for Weaviate, it's a 14-day free trial. For Qdrant, it's pretty nice. You get 1 GB free forever. Milvus or Zillis Cloud is also a very generous free tier. The cost is estimated, of course, it's depend on how much you store, how much you write your index, and how much you query. And here is a rough estimation for if you store 1 million vectors, and each one is 1,536 dimension. And this is the cost estimated by all those vector databases, the cost calculator. So for example, if you go here, and so you can use those price calculator to specify your collection, number of written, and storage, and what's your query load, and then you will get a estimate cost. If this is probably too high, you probably wouldn't have that many. Try another one, see Pinecone. You can also estimate it based on your vector dimension and a number of vectors, and let's say you also have total query per month, let's say it's 1 million, and total writes per month is 1 million, and that's how you get the $30. All of those are clickable. You can just do the calculation based on your use case very easily. I included some of the more details for how I evaluated those different criteria. Critical lessons learned is metadata schema flexibility. Metadata fields for indexing must be declared at index creation, which is not very flexible. One final recommendation is if you are budget consciousness, and then Pinecone is pretty good, but be aware of the limitation. Best balance, I would highly recommend Qdrant. On the slightly more expensive side, I would recommend Weaviate because they have very good hybrid search capability. All right, that's a wrap for today. If you find this is helpful, feel free to fork the repo, drop me a comment. Thanks for watching. See you next time. Happy Halloween.